Okay, Summer Physics 3-4, we're on to our next lesson in electricity, and this has to do with series circuits. So what does a basic electrical circuit look like? A basic electrical circuit includes a power source, such as a voltage source, that would be like a battery, a device that uses the power, such as a resistor or load, just think of a simple one as being a flashlight, and a switch that opens and closes the circuit. So there you see the voltage source on the left. You see the resistor or load on the right. That's the jagged line. That could be the light bulb of the flashlight. And then the switch that allows the electricity to flow or not flow. The voltage source provides pressure on the electrons at all times. But electrons only flow when the switch is closed. This is called a closed circuit. No electric current flows in an open circuit. So with that switch open, that means the flashlight is turned off because the electrons cannot get around that square loop that you see there. You'd have to put that switch down so that there's a contact between, so the entire circuit is closed, and that allows the electrons to flow around from the voltage source over to the light bulb, and then they go back from the light bulb back to the voltage source. What is the relationship between current, voltage, and resistance? So the relationship between voltage, current, and resistance is given by Ohm's law. And it's voltage equals current times resistance, or V equals IR, where V is voltage measured in volts, current is measured in amperes or amps, A, and resistance is measured in ohms, which is the omega symbol. So example 1, how much voltage is required to push 5 amps of current across a 2 ohm resistor? So we break down the problem. So voltage is equals question mark. That means that's what you're looking for. You're trying to find voltage. That's what the question mark means. Current is 5 amps, I equals 5A, and resistance is 2 ohms. Okay, so we have the formula V equals IR, so voltage equals 5 amps times 2 ohms, so the voltage is 10 volts. So that means that 10 volts is being, there's 10 volts of electrical pressure in that battery, and it means that those 10 volts are all being used up over in the resistor. That's the light bulb, that's the load, that's what's using the voltage and the current, and that's in the resistor over there. How much current flows when 20 volts is placed across a 5 ohm resistor? Okay, so now you're looking for the current. You're given the voltage, you're told it's a 20 volt battery, and the resistance, that would be the light bulb, is 5 ohms of resistance. So how much current is going to flow across that? So now you need to rearrange the equation, Ohm's law. So you're looking for current, I equals question mark, and you're given the voltage of 20 volts, the resistance of 5 ohms. So there's V equals IR. Now you got to do a little bit of algebra. You got to solve for I. So you divide both sides by R. That's the red R's on the right and the green R on the left there. The R's cancel out on the right side, and you end up with I equals V over R. Okay, that's just a little bit of algebra there. So now you come back and you plug in the numbers. So I equals 20 volts over 5 ohms. And volts over ohms is going to give you amps, which is the unit for current. So 20 divided by 5 is 4 amps. So that's how much current would be flowing through that entire circuit. So how does voltage and current change as we go around a circuit? Alright, so across a resistor, just kind of memorize this top red box. Across a resistor, voltage changes but current doesn't. So let's look at this. So the 10 volt power source and the 2 ohm resistor create a constant current of 5 amps the entire way around the circuit. So there's 5 amps all the way around that square, that square box, okay? It's 5 amps. Now what sets that? What sets that 5 amps all the way around is the 10 volt voltage source and the 2 ohm resistor, which gives you 5 amps of current. And again, it's 5 amps all the way around. Before it gets to the resistor, it's 5 amps. After it gets to the resistor, it's 5 amps. Remember, current is how fast the electrons are flowing. So think about it. one electron, the electrons can't be flowing any faster or slower than the electrons in front of them or the electrons behind them. They all have to be going at the same speed. So therefore the current is going to be the same all the way around a circuit like this. It can't be faster in one place than the other, otherwise the electrons would bunch up in that one place where they're faster. So it's 5 amps all the way around, from the battery all the way around through the resistor and back to the battery. The voltage is 10 volts at every point along the red wire. So you see all the 10 V's there? Everywhere where that wire is red is 10 volts. That's how much pressure there is. Once the voltage crosses the resistor, it drops down to 0 volts at every point along the green wire. So whatever voltage the battery is putting into the circuit, it all has to be used up in the circuit before it gets back to the battery. So again, in going around that circuit, the current is set by the resistor and the voltage, but once it's set at 5 amps, it doesn't change. It's not higher in the red wire and lower in the green wire. It's the same, 5 amps. But the voltage is 10 volts up in the red wire, and then once it crosses the resistor, that's the light bulb in your flashlight, it then drops down to 0 volts. So again, reading that top red box, across a resistor, voltage changes, current does not. A series circuit contains 2 or more resistors, and they're lined up one after the other. So 2 resistors are in series when all of the current that comes out of the first resistor goes through the second resistor, and all of the current going through the second resistor has passed through the first resistor. In the circuit below, all current that passes through resistor 1, that's R1, must pass through resistor 2, R2. Why? Because there's no place else for it to go. It's like a hallway that has no doors. There's nowhere else for that current to go. So anything that comes out of R1 has to go down through R2. And then also everything that goes through R2 had to come from R1. There's no place else it could have come from. So this is a very simple circuit. So those 2 resistors are said to be in series, one after the other. So how do we compute power? To find the power that a device in an electric circuit uses, we use the following equation. Power equals voltage times current, so P equals V times I. To calculate the power used in a particular circuit element, such as a light bulb or a fan, we can use the equation also, P equals I squared R. So you can use either one of those. Again, it depends on which of those variables you have. If you're given voltage and current, you use the first one. If you're given current and resistance, you use the second one. The unit of measure for power, well, it's not again, we haven't gotten to this yet. So the unit of measure of power is a watt. So you've probably heard that term before. Electrical power is measured in watts. Okay, and that takes care of this brief lesson on series circuits. Tomorrow we'll learn about parallel circuits, and we'll also do some series and parallel circuit problems.